Okay, here we go with a question which is about circular motion. Okay, feel free to have a go at the question, and when you're ready, hit play and have a watch of the explanation. All right, let's go for it. So here we're looking at the ball, mass 0.4, we've got a string of length 0.8, we'll assume that's constant, and we've got the speed at the lowest position, which is 6 meters per second. Now the question is asking us, what's the tension in the string when it's at its lowest position? Again, I would say this is a fairly classic question. I've seen questions which have looked at the tension at the top, or thinking about the ratio of tensions, etc. This one we're looking at just simply, what is the value of the tension? To do this kind of question, it's always worthwhile to remind yourselves of a little bit of information regarding circular motion. First thing to do is to identify a central point, because we need a centripetal force. Okay, now our centripetal force is going to act towards the center. Okay, now we're at the bottom, that means it must mean that we provide a force which is acting upwards. Now in this particular situation, we're going to have a tension force pulling up and the weight which is acting down. So what I've done is a force balance. I've taken my tension, which is acting upwards, take away my weight, which is acting downwards, and those two must combine to make mv squared over r. In other words, the centripetal force. Remember, we say that these two forces combine to provide a centripetal force acting towards the center. Okay, now we do a little bit of rearrangement. Okay, I'm going to bring that mg onto the other side, and I'm going to have tension equal to mass times g plus v squared over r. And these are things that we know. We know v, 6 meters per second. We know r, 0.8. And we know the mass is 0.4. We also know g. Now in this case, we're just going to use g equals 10 because this is multiple choice. Okay, I mean, to be honest, it wouldn't make much difference either. Okay, we're going to end up with a nice answer here, which is 22 newtons. And the answer here is D. Now, something to think about would be a follow-up question, which is what's the tension at the top? When we're at the top, we're going to find a lower tension. And the reason for that is the mass is exactly the same. We're going to have, instead of T minus mg, we'd have T plus mg. The reason for that is that both the weight and the tension are going to act in the same direction. So if you wanted to, you could calculate that tension at the top as well, exactly the same calculation. Instead of a minus here, you'll have a plus, a minus here, a minus, and a minus. Okay, I wouldn't be surprised if that came out as one of these lower numbers, but I haven't tried it, so I'm not going to guarantee anything anyway. All right, as I say, very classic setup for a question, but they're asking something different this time. Any questions, feel free to ask.